Okay, so this is my equation I'm going to use. Actually, stare at it for a second. I actually haven't done much, if you think about it. All I have written is I have said F equals dP over dt, which is dm over dt. M is changing, so it'll be just dV over dt plus dm over dt v. That's it. And the only other thing that I've actually done is I have redefined this v in terms of relative velocities of the two. So now consider some specific cases. Remember I said sigma f equals ma is a specific case of dP over dt. And when did that happen? When delta m was 0. Right? When the change in mass was 0, then only this exists. Now let's talk about the equation that we have. I'm going to erase this. So there are many different cases you could think about. The first one, let's do one, would be when we are gaining mass and small particle is at rest initially. What will happen to, I'm going to call this equation A. What will happen to equation A? F external will just be m dV over dt plus dm over dt. What was VR? U minus V. Initial particle, the tiny particle is at rest. What happens to this U? Goes to 0. And some other magic happens. M dV over dt plus dm over dt U. And may I write this as d over dt of F external equals. Oh, wait a minute. I wrote inside out. This should be the other way around. This should be V and this should be U that goes to 0. Right? Because P is nothing other than M times V for the large mass.